Hello everyone. Today we'll talk about the solution of the problem maximum matrix sum. We see by definition of this operation that we cannot change the absolute values of any elements, but we can select any two adjacent elements and essentially flip their sign. So put a negative sign in front of both of them, and two negative signs cancel out. So to maximize the sum, we want to get rid of as many negative signs as possible, and if some negative signs remain, we want them to remain next to elements that have small absolute values. So what can we actually accomplish using this operation? There is this common pattern. For instance, probably the first place where we can see it is when analyzing bubble sort, which is a sorting algorithm that swaps adjacent elements. And an easy thing to notice is that if you can swap adjacent elements, you can also swap any two elements with each other. You just swap adjacent elements until the two are next to each other, then you swap them, and then you perform the same swaps in reverse, and now everything in the middle is the same, and the two elements at the end are swapped. What does this have to do with our operation? Well, our operation is kind of similar to a swap, in that it performs this weird thing with negative ones. And we can, if we want, because of course we can turn two positive numbers into two negative numbers. That's not the best of ideas. We can take two negative numbers next to each other and turn them both positive, which sounds like a good idea. And then we also have a situation where one number is positive, one is negative. So if we have a plus and a minus, then we turn it into a minus, then a plus. So we essentially push the minus in one direction. And in the same way as bubble sort, when we have, let's say, a minus here and a minus here and want to get rid of them, then we can take any path between them and get rid of them, if that path is over all positive numbers. So we can, any pair of elements that have minuses at the beginning, we can get rid of those negative signs, make those elements positive. And can we get rid of all the negative signs in this way? Well, we almost can, but we cannot guarantee it. That's because this is a very simple invariant. After every operation, the parity of the number of negative signs stays the same. So if we had plus plus, we get minus minus, so we get the same parity because we add two negative signs. Likewise for this operation, of course, plus minus, minus plus go to each other. So here the number stays the same, here the number decreases by 2, here the number increases by 2, but still the parity doesn't change. So if the number of negative signs is odd at the beginning, then it will stay odd, which means that the lowest odd number, 1, one element will have to have a negative sign in front of it, and you want that element to have as small absolute value as possible, preferably for it to be 0. And so we do not have to simulate all those operations, we just have to look at the elements, select the element that will put a possible negative sign at the end, and we also have to keep in mind if it's even necessary, so we have to count the number of negative signs, or the parity of the number of negative signs. And now looking at the code, an example implementation will be keeping in mind the total, so the absolutely optimistic sum of all the absolute values, the count of values which are negative at the beginning, and the minimum absolute value, which will be the unlucky element that might get the one negative sign. And now for every element in our matrix, we add its absolute value to the total, and we see if it's possibly now the new minimum absolute value. And if that element was less than 0, we have another negative element. And now if the number of negative elements is odd, so we can just end it with a 1. So if this neg count is odd, that means that one number has to get a negative sign at the end, but we choose that number. That number should be the number of minimum absolute value, preferably a 0, and we have to subtract it twice from the total, and we return the total. We have to subtract it twice because here we added it, so we assume that it will have a positive sign, but unfortunately it has a negative sign, so we have to subtract it because we have mistakenly added it, and then we have to subtract it again because it has a negative sign. And this is the whole solution.